We're on example 4 now. We have 4 minus sine theta. So let's see if we can't find the maximum R values. So we know that it's nice, it's a sine theta, so we don't have to do any of that angle dividing that we did for the cosine 3 pi. So we know sine has to be between 1 and -1, so first I put -1 in for the equation for sine theta. So absolute value of R is 4 minus -1, which is absolute value 5. And then I get R equals 4 minus a +1, and I get the absolute value of 3. So this is going to be my maximum. So 5 is obviously greater than 3. So I set 5, R equal to 5 to find the angle. So 5 equals 4 minus sine theta. So then I added sine theta to the left. Sine theta plus 5 is 4. And then sine theta equals -1. So where does sine theta equal -1? At 3 pi over 2. So here is my answer for the maximum R value. The absolute value of R is 5 at theta equals 3 pi over 2. So if you get to 3 pi over 2, you will see that it is 5. Okay. Now, when I did my graphs, I did backwards points because of the symmetry, and so here negative pi over 2 is the same thing as 3 pi over 2. So there's my 5. Okay, zeros. Set R equal to 4. No, set R equal to 0. So you get 4 minus sine theta equals 0. So sine theta equals 4. So never. So there's no zeros. Never will go through the origin or the pole. It's a sine, so is it symmetric to theta equals pi over 2? Let's test it. If you put in R and pi minus theta, you get yes, that is symmetric. We did that in the other lesson. So I know that I have a symmetry going down the line theta equals pi over 2. So I'm drawing that in on my graph in orange right now. Which means when I plot, I only have to plot from here to here. And I only need to do these points. So, okay, I'm going to do here, 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 here. Of course, here and here. Now, I already learned that at 3 pi over 2 or negative pi over 2, it was 5. So I can plot that point right there. And that's as big as it's going to get on that polar graph. And here's me putting in y1 is equal to 4 minus sine theta and doing ask. My first ask would be pi over 6, and I got 3.5. Now, you can do these without a calculator, but you're only going to be able to do the ones that come out even. So that's why we get the rest of them with the calculator. So 3.5 for pi over 6. So I'm going to, okay, this was positive pi over 6. Let me get rid of all this orange stuff on this graph. Okay, so at pi over 6, I was at 3.5. So pi over 6, 3.5. Looks like it's about there. At 0, it was 4. And so because it's symmetric, I can look over there, and at the matching pi over 6 over here, which is 5 pi over 6, I have 3.5. And also at pi, I have 4. So I got those points. I've done this one and this one. Okay. So now I will do pi over 3. On the calculator, it equals 3.1. So I'm back over here on the graph with my orange dot. So at pi over 3, it would be 3.1. And then across, it would be 2 pi over 3 is 3.1. Okay, at pi over 2, we're at 3, and there's no symmetry. It's right on this line of symmetry, so don't have a second point for that one. All right, now I've done all these now, which gave me all of these, and now I'm going to do these points, which will give me these points. Make sense? Okay, So I'm going this direction. I start at negative pi over 2 and I get 5. That was the point that was found from our maximum. And then at negative pi over 3, which is this point right here, 5 pi over 3 is negative pi over 3, I get 4.9. And so across the axis it would be 4.9. It's matched, so that was negative pi over 3. And now at negative pi over 6, which is 11 pi over 6, I'm over here, I have its match at 7 pi over 6 of 4.5. So that's the shape, all right? It's a circle right there. So that was example 4. I think there's one more example.